Okay, class, we're going to do a quick review on graphing linear systems. So here are two equations. We are going to graph them one at a time. First graph this top one and highlight it blue. Highlighting will be optional. You will have to graph things in pencil because it needs to be detailed enough for that. Okay, so first off, when you're graphing an equation, the first thing you look at is the second number. Remember that, that's very important. That's where you start, and you start on the y-axis. Notice I labeled this vertical one as the y-axis, so that means I'm going to start down 5. So from the origin, go down 1, 2, 3, 4, 5, right here. Put a nice point there. And then, from that point, we have to use the slope, 3. So we can rewrite 3 as 3 over 1. Now remember, slope is rise over run. So we're going to rise 3, run 1. Now what does that mean? Well, as long as those are positive numbers like they are, rising 3 means up 3. And running 1 means right 1. So from this point that we plotted already, we're going to go up 3, 1, 2, 3, right 1. Make another point. Now make sure you're paying attention to all this. We are taking a quiz on this shortly. Now you can do this again and continue the process. Up 3, 1, 2, 3, right 1. And it's pretty easy once you get the pattern down. Up 3, 1, 2, 3, right 1. 1, 2, 3 up, 1 right. And we can fit one more in there, right there. Okay, now, actually, you might notice that you can fit another one going to the left of this first point that we made. And you do the exact opposite of going up and right. You can go down 3 and left 1, and it does the same thing because you can see that all these lines are still going to make a nice straight. All these points are going to make a nice straight line. So the next step is to draw that line in. Okay, like so. Notice how it hits every point. Awesome. We'll highlight that in blue to show it goes with that top equation, and you can see how thick that is when you use a highlighter. That's why you also need to use a pencil so you can see the detail. All right, now the next one is this other guy. We'll graph this one in yellow. Okay, so right here. So again, we start off with this second number. That's our y-intercept, so that means positive 6, up 6 from the origin. 1, 2, 3, 4, 5, 6. Nice point right there. From there, we are going to use the slope. Notice that there's a negative right in the middle of the fraction. I like to move that up to the top so it's on one of the numbers. You could move it to the bottom, but just to be consistent, I always go to the top for that. And that's rise over run. So for rising, remember I said if it's positive, it's going to go up, but now it's a negative, so it's actually going to go down 2. That's a positive 3, so the running will still go to the right 3. So from this red point, I'm going to go down 2, 1, 2, and right 3, 1, 2, 3. Actually, that's awesome because look, it hit another spot, another specific point on the blue line. So that's good. We could basically be done right there when we draw a line, but I like to do a couple more just to make it look, the line looks nice. So down 2, right 3, maybe one more, down 2, right 3. Okay. And let's graph it through all those red points. Voila. Use our handy dandy highlighter. And there we go. Notice that in the intersection, it is green. Okay, that is our point. That is the solution. Okay, so in this case, the solution is right there. There's one solution, but don't forget to write it as an ordered pair. So what's the x-coordinate there? So we go over 1, 2, 3. So the x-coordinate is 3. And the y-coordinate is how high up it is, 1, 2, 3, 4. So that's our solution, 3, 4. All right, remember there are a couple other scenarios that you can come up with. This is just one possible situation. Another scenario is it can be consistent and independent. That's when the lines are on top of each other. I'll tell you right now, the quiz is not going to have any of these situations, okay? So you won't have to worry about this one with infinite solutions on the quiz. Um, you could also have no solution, and that's when the lines are parallel and they'll never cross, okay? This is a situation where they have the same slope. That might be good to know. Same slope here. And notice I also said I did not say that it won't be on the quiz, so maybe that'll be on the quiz. All right, you can go ahead and pause this video. Good luck on the quiz. Do your best. Hope I see some good results. We'll continue the video with substitution after everyone has finished the quiz. All right, at this point, everyone should have completed the quiz and receive this note sheet that looks like the one that you see on the screen now. All right, so we talked about solving linear systems by graphing. Now we have this another method called solving by substitution. The nice thing about this method is there's no graphing, so that's pretty awesome. Okay, so notice we have two linear equations as before. You can tell that they're linear equations because they're in that same form that we've been looking at. So if you were to graph each of these, they would make a line. Okay. All right. So now that uh, we have them both in this form, y equals 3x minus 3 and y equals negative x plus 5. Since we want to know when they intersect, that means when the x and the y are equal to each other, well, we want to know when uh, this 3x minus 3 is going to be equal to this negative x plus 5 because they're both equal to y, and y must be equal to itself. So it's kind of this is called the transitive property. Since 3x minus 3 is equal to y, and y must be equal to y, and y is also equal to x negative x plus 5, that must mean that negative x plus 5 is also equal to 3x minus 3. Not quite sure if you followed all that. Another way you could look at it, get rid of those arrows, is that since y is equal to negative x plus 5, you can plug in all of negative x plus 5 in for the y of the other equation. So you're going to substitute the circled thing, the yellow thing, in for the y up here because it's equal to this y, and these y's are the same. So substitution, you can think of it as like a sports team, one person goes in for the other kind of thing. This is one thing going in for another thing because they're equal. All right, so let's see what that would look like. So now I'm going to rewrite this, but now negative x plus 5 is equal to, and that is going in for this y, and the 3x minus 3 on the other side. Okay, so now we have a new equation. The nice thing about this is there's only one variable now because you have an x. Or I should say there's one type of variable. There's two x's, but there's no y's involved here. So there's just one type of variable. Okay, so now if you guys remember the James method, the Mr. James method, we're going to move the x's to the same side and move the non-x's to the other side. And remember, so let's move all the x's to the left. So when you move it, its sign changes. This positive 5 is going to go over here. All right, so let's see what that looks like then. So now all the x's will be on the left. So the negative x already stayed over there, so it's still negative x. But this positive 3x, once I move it, it becomes a negative 3x equals. This positive 5 is going to become a negative 5 when it gets moved over. And of course, this negative 3 stays negative 3 because it didn't move. Now you could use a calculator if you want. Remember, this is a -1 in front of that x. Sometimes it's nice to draw that in. And you can have -1. Since these are both x's, you can combine them. -1 minus 3. You can use a calculator for that or do that mentally, either way, but that's -4x equals -5 minus 3. That makes -8. All right. Now, hopefully you remember how to solve this is a one-step equation. All you have to do is divide by 4. Because this is -4 times x, you can divide both sides by -4. The -4's cancel, and x is equal to, well, -8 divided by -4. A negative divided by a negative makes a positive, and it's a 2. Okay, so x is equal to 2. Now, that's good, but we also need to know what y is equal to. So what we now need to do is plug this 2, this x equals 2, in for an x in this equation or this equation. And then we can solve for the y. And it's your choice. Either the one that I highlighted in blue or the one I highlighted in yellow. I always say pick the one that looks easier to you. Since there's a negative on this one, maybe it'll be easier to just multiply it by 3 first. So I'm going to use this top one. But you can't go wrong with the bottom one either. So now that's going to look like, I'm going to show my work over here, y equals now 3, and I'm going to substitute, remember that word again, substitute, this 2 in for the x, because it says x equals 2, therefore I can plug a 2 in for it. So here's a 2 minus 3. And then we can solve for the rest of this y. Well, what's 3 times 2? 6 minus 3. 6 minus 3, that's 3. So that's our y value. So our x value is 2, our y value is 3. We can now write our solution as an ordered pair. Remember, you always write the x number first. So parenthesis 2, comma 3. And that is our solution. That is the substitution method. All right. Now I want you guys to try out a few of these problems on your own. Okay. Do the best you can, and I'll see you Monday.